Okay, so in this video I'm gonna review standard to vertex, how to go from standard form to vertex form by completing the square CTS. And once we have it in vertex form, we're gonna solve the equation. Basically, we're gonna find the roots, the solutions, using the square root method, which is an algebraic form. Okay. Yes, we can always go to decimals and find them in decimal form if we have to. All right, so when I look at this, one of the first things I see, this is standard form. I can see that my A is 1, my B is 6, my C is -7, and I pay attention to this one, that this one is even. So that means it's going to be a little bit easier to work with. Okay. So now you gotta make sure you're paying attention on this. First thing you're going to do is you're going to create some space between the linear term and the constant. Okay, so this space is not necessary, but we need a little bit of space right here. Once you have the space, the next thing you're going to do, so step 1, make a space, make room. The second thing you're going to do is take B and divide it by 2. So 6 divided by 2 is 3, correct? 6 divided by 2 is 3. And then you're going to square B over 2. Okay, droop, squared, and that gives us 9. Once we have this, watch what we're going to do. I think I might need to move this a little bit. Oops. A little bit this way. Here we go. Okay. Change the color. The 9 is going to go here. It's a positive 9, so we're going to say plus 9. Now, we are on the, right, this is the equal sign, and we are on the right-hand side. And we can't just add 9 if we can't add 9 to the other side. So in order to undo this 9, not only are we going to add it, but we're also going to subtract it. Okay, so now we're back to point A. 9 minus 9 is 0, so we haven't changed anything. Right, and that's pretty much it. What you're going to find is that this part right here is what's known as a perfect square. 9 is what we needed to complete the square. Okay. When we factor this, you're going to find that it looks like this. It's going to end up looking like this. Y equals this right here. Going to factor into x plus 3 squared, perfect square, x plus 3 times x plus 3. All right, and yes, you can note that that's the 3 that we found. That's this 3 right here. Okay, and the rest is just do the math. Put this in your calculator. What's -7 minus 9? Okay, number 4, write your x plus b over 2 squared, and then sum the constants. So that's going to be -16. Okay, so how do you know if you did it correctly? Because, you know, you can always check in delta math decimals. Let's type in the original one. Y equals x squared plus 6x plus 9. And let's the one that we wrote. Y equals x plus 3 squared minus 16. And as you can see, they're not the same one. So that would be because what I typed this in. I should have typed this one in. I am so sorry. X squared plus 6x minus 7. That would explain why. All right, so this one is the original one. It's this right here. And this is the vertex form that we wrote. And what you see is if I remove the blue, never mind, if I remove the red, blue, you see? So they're equivalent forms. This is in standard form and this is in vertex form. All right, in order to find the solutions, yes, those 2 points right there, you could click on the graph and get the solutions, you know? You just say, well, Miss Medina, according to the graph in Desmos, my solutions, right? What was it? My roots, my zeros, my x-intercepts, right, are x equals -7 and x equals 1. Yes, but I have to show you how to get that information. Let's say that you don't have the graph, Desmos. You have to be able to, okay, so how do we get these numbers using, okay, the square root method? Right. So now we're solving, okay? We're solving for the roots. Okay? So you're here, y equals x plus 3 squared minus 16. Now, what is the y value when we're talking about the roots? The x-intercepts, the y values are always going to be 0. You'll see? Okay. And now we're going to solve for x. So we're going to add 16 on both sides. So we have 16 equals x plus 3 squared. Right, we love to solve for x, but we can't because it's trapped inside the parentheses. Right, and the parentheses are squared. So we have to get rid of the square first. And we're going to do that by taking the square root. And if we do this on the right side, we also have to do this on the left side. So the beauty of this is very simple. The square gets canceled by the radical sign. And what's the square root of 16? I don't know if you remember, but there's two numbers as the square root of 16. It could be positive 4, correct? Or negative 4. So if it equals positive 4, this would be x plus 3. If it equals negative 4, do it separately. So this actually, it's a perfect square, so we know it's going to be either positive 4 or negative 4, right? Some people write it as plus or minus 4. So plus or minus 4 is going to be equal to x plus 3, right? The radical sign is gone, the 2 is gone, and then we don't need the parentheses. So this is actually two equations. It's 4 equals x plus 3 and negative 4 equals x plus 3. Alright, since we want to solve for x, we're going to do minus 3. We get that x equals 1. Check. Check. And for this one, I'm going to subtract 3. But these are both negatives now, so it's negative 7. And that's the other one. Check and check. So, yes, we can get the roots via Desmos. But this is what the square root method would look like. I hope you enjoyed these 10 minutes of completing the square, to take standard form and put it in vertex form, and then use the square root method to solve that vertex form to find the roots, which are 1 and -7. Okay. Which we could have gotten the vertex from here. We could have found our A.